ASM robot is an autonomous machine which can survey a given land, field or region without any human intervention. The conventional way of surveying an area requires a lot of human effort and time. This method might cause degradation of land, which results in rendering the area useless. Sometimes the area which is to be surveyed is not suitable for humans. Thus, an autonomous machine will be very much helpful in surveying an area. For making an autonomous machine, the hardware which we have used is National Instruments Compact RIO 9075 and digital input-output and analog input DAC modules, along with National Instruments Graphical Designing LabVIEW software. Basic features of ASM robot: surface monitoring, automatic surveillance, obstacle avoidance. Surface monitoring. Under surface monitoring, we are measuring the moisture and temperature characteristics of soil while surveying an area using Vegetronics VH400 soil moisture sensor and Therm 200 soil temperature sensor. Also, in order to consider the surrounding humidity and temperature as reference point, we have used HSM 20G sensor. Here is the video demonstration of surface monitoring. In this video, the ASM robot moves to the point of survey and starts survey mechanism. The sensors are dug into the soil to measure the soil characteristics. Bump sensors are used to limit the motion of the motor as shown in the picture. The data collected by the sensor is stored along with the coordinates of x-axis and y-axis with the help of LabVIEW into the spreadsheet for further studying the properties of soil. Thus, in this way, it performs the soil survey. Automatic surveillance. Under this, the length and width of an area to be surveyed is given into the LabVIEW along with minimum required grid length and width. LabVIEW divides the area into grids of length and width of equal dimensions. It then calculates the effective grid length and width along with the number of grids in x-axis and y-axis and shows them onto the front panel. The front panel of the program contains a picture which shows the path traced by the ASM robot shown by a line along with the points of survey as shown by red dots. To measure the distance traveled by ASM robot, we have used IR sensor which has IR transmitter and receiver pointing towards the tire, which consists of black and white strips which determine the rotations per minute of the wheel. Here is the video demonstration of automatic surveillance. The grids are marked by the red lines in order to show the path which will be traced by the ASM. The grids are shown here by box of 60 into 60 cm each. The grids are numbered in the chronological order in which robot surveys the area. Robot starts the survey in the first grid. Now it moves to the second grid and starts survey into that grid. Further, moving on to the third grid and again performs its survey. It takes right turn to move on to the second column of the grid. And moves to the fourth grid and performs the survey. And so on, it carries out the survey. This picture shows the path traced by ASM along with the point of survey with red dots. Black lines here shows the return path which is taken by the ASM in order to reach the initial point. obstacle avoidance. Here is the logic of obstacle avoidance. In order to avoid the obstacle needs to be sensed by the ASM robot. ASM robot alters its path and returns to the original path after avoiding the obstacle. These are the TSOP IR sensor mounted in front of robot in order to detect the obstacle. Here is the video demonstration of obstacle avoidance. The box shown is used to represent an obstacle for ASM robot which is to be avoided. The ASM senses the obstacle and alters its path. And then gets back to its original path, thus avoiding the obstacle. How is our ASM robot better than conventional method? ASM surveys the region without degrading the land. It is fully autonomous with the help of lab view, and thus human effort is drastically reduced. The data collected by the ASM is much more accurate than conventional method. Also, it saves a lot of time.